Hi, okay, welcome to our next session. It's quite a big one, so it may be one that you decide you need to take a break in as you work through it. If you're starting to feel fatigued, if you're feeling like you're taking on a lot of information, then obviously take those breaks. Really, really important. It's hard to learn if we are feeling overwhelmed or tired by the amount of information that's coming in. So just do it at the right pace for you, basically. We're going to start off with our recap. So there's a few questions for you, and when you're ready, hit play for the answers. Okay, here we go. There we are. All right, so again, normal thing, just take your time, pause to look through it all properly. And I'm just going to give the reasoning behind the circle theorems when you're ready. Okay, so just a couple of things that I wanted to mention. First of all, I just wanted to mention the fractional indices here. So we've got the fractional indices on a fraction, which can be quite off-putting. Don't see this as anything more than working separately with the numerator and denominator on whatever rule you've been given. And I think that sort of clearly demonstrates what we're doing there. Didn't worry at all about the negative until the very end when I just flipped that over. And then onto this one. Remember, we should be always writing down our reasons for why we do things. On a very complicated question, sometimes they just leave you to get on with it. But if there's only 2 or 3 steps, then there's a chance they're going to ask for those reasons as you go. So write them as you go. Okay. So let's have a little look. The first one to go for is the X. Okay. Because the X is going to help it feed into the rest of the diagram. But please remember that the busier the diagram is, the more lines, then the more routes, the different ways that you can do it. So if you have done it differently to me, but you've got it right, and you've got all the evidence to back it up, then you know you're getting full marks, okay? But for me, this is how my brain processed the question. So first of all, I noticed that the center had this angle of 230. So I found this one by just using angles around a point of 360, and that got me the 130. From there, I was able to get this angle here, which is 65 degrees. 65 degrees because it's half that of the angle at the center. So that angle theorem was being used here. Then I used the alternate segment theorem. So the X here, okay, is being made by this tangent in chord, okay? The angle opposite is equal, and we've already worked out that that is 65. So X has to be 65. At this point, it kind of opened up a few different avenues for me. So I went on and found that the 25 degrees, in fact, let's just zoom in a little bit so it's a bit clearer to see what I'm looking at. There we go. I was able to use the tangent and radius rule being 90 degrees here. And because X is 65, it meant I was able to work out this angle here was 25 because of the 90 degrees. And I could then go on and work this one out because angles on a straight line add up to 180. So I popped that one in as well, not really knowing at this stage which one of the two were going to be useful to me. I then considered this triangle and thought, well, I've got enough information now to find this, which turned out to be 25 as well. So this was an isosceles, even though it didn't clearly show me that with any markings. And then I was able to basically use angles in a triangle for a second time to find my y, because I've got this triangle here. And I know this angle, and I know this angle, and I know a bit of this. So 180, take away all these angles I know, is going to equal the angle that I needed to find, which is 35 degrees. So I was very happy about that. You could equally have used the alternate segment theorem, because the 60 degrees here that they've given us obviously lies between the tangent and the chord. So the opposite angle is going to be the same, 60. And 60 take away 25 is again 35 degrees. So that is what is happening with that circle theorem. Hopefully that went well. So let's move on to what we're actually going to be doing today. It's looking complicated already, isn't it? Let's just make the page a little bit smaller so we can get everything clearly on. There we go, that's good enough. Okay, how are we going to make our basic trig, our SOHCAHTOA, harder? Okay, it's got to develop, it's got to come out of just the basic, here's a right angle triangle, find a missing angle, or here's a right angle triangle, find a missing edge. That is very much your grade 5 foundation, kind of the basic understanding of SOHCAHTOA. Now, we need to develop our application. We need to be exposed to questions that force us to think more deeply. The more we are exposed to these, the better our critical thinking skills will become. And it's those skills that are going to give us the best grades. We are absolutely not about, I recognize that question, I can answer it. We are about, I've got this knowledge, how can I use it? If you want the best grades at higher GCSE, you have to be that kind of student. If you're only ever looking for a question you recognize, then there's going to be so many you can't answer or gain a mark here or a mark there from that you're really capping your own progress. So I can't stress that enough. And I know it's something that I mention frequently, so I'm sorry if you keep hearing the same message from me. So the first thing that we're going to look at is trig values. There are a handful of exact values that we are expected to know. We're expected to have this in our memory, ready to use if a question comes up. And what it enables the examiner to do is put trig on a non-calculator paper. So that's what we're looking for, okay? Now, if you were to Google a table of values to help you remember them, you will get this one and this one. These are the main two that come up. This one is like the perfect table. Everything is exactly how it is as a simplified fraction, although you could argue that we would never leave an answer with a surd as a denominator. However, we're only using this value to get to 45 degrees, that type of thing, okay? So we don't need to worry too much about it. But that said, this one here does require us to think about our surds because it won't give us a simplified fraction. So you've it swings and roundabouts with these two. There is a pattern with the sine in the cos, which means you only have to remember one. So once you've learnt that order, then you just write it backwards for cos. And then you've got the tan to learn as well. The reason that there is a second separate different set of tables, and these are just equivalent values, they actually equal the same thing, is because this one is considered easier to remember. If you look at the sign, it goes 0, all the denominators are 2, that's nice and easy, and then it's root 1, root 2, root 3. But like I say, this one can cause the odd issue. It's not massive. So if that was the table that you could really only get into your head, then that is absolutely better than nothing. And it's still going to do the vast majority of questions. But like I say, there is just this odd occasion where you'll get a question and it just doesn't quite work out without that extra step of surd work. And if we can avoid that, I think it's probably sensible. So my preferred table is actually one that kind of combines the two of them. So it's an adapted version of the two go-tos. And it's certainly the one that I use in my lessons with my classes. We don't have any problems. So I know it's a successful table. So let's take a quick look at this one. It isn't vastly different, okay? It's mainly the first table with a tweak, okay? So you can see if you look at tan on the first table and on mine, exactly the same. Okay, I quite like this version because actually you really just need to remember this 1/√3, and then it gets split with the 1 being in the next box and the √3 being in the next one over. So remember this and then split it across the next 2 boxes and you're done. So that's quite nice. This one here, okay, obviously you've got to come up with something that's going to help you, okay? So the way that, again, I teach this is learn sine, and then you just have to write cos backwards. So it's only 1 row to learn. And then when you look at this, obviously 0 to 1 is nice because that's in numerical order, easy to remember. And then the roots kind of go down and up. They kind of make a V. Okay, so it still goes √1, √2, √3. So nice and easy for that reason, but down and up. So you could think of it as like a V. V for victory. Trig is not getting the better of us. Whatever silly little way you can come up with that's going to help you remember, use it, okay? And obviously the other thing is write it out. Write it out lots and lots and lots. That will make a difference. And put it on your like poster of what I must remember. So every student should have this kind of page or poster, whatever you want to call it, with all the facts and formulas and details that you're not going to be given in your exam. And yet, if you don't have that ready to just recall, it's going to hold you back. It is a memory test and it feels very unfair. We won't get into whether I agree with it or not, but we have to do it whether we like it or not. So we're going to be using the third table throughout, and let's get on with it. Let's see it in use. So here we go, our first question. All right, now I am assuming that you are comfortable with your basic SOHCAHTOA. So if you've started this session not having done trig for quite some time, this could be where you stop, go and take a look at how that works, okay? You know that I've got my YouTube channel, so there's a quick how-to on there so that you can check in with this, or stick with me because I'm still going to talk through everything that you need, and that might just be enough anyway. Okay, so first thing that I'm going to do is label my sides, okay? So this is my angle. So straight across the triangle is my opposite. So I always do them in this order. It's just my routine, my habit. I then go to my right angle, and right opposite my right angle is my hypotenuse. And that leaves the last edge as my adjacent. I then look at what is going to help me solve this particular problem, okay? H is because I have a value. A needs to be in it because it's what I'm trying to work out. So A and H are the important edges. So then I would write out, oops, SOHCAHTOA. I would highlight the A and the H. It's there side by side. So it's the cosine rule that I need. So it's cos theta, that's my representation of the angle, equals A over H. And then I start taking the information from the diagram into my trig function. So I've got cos, the angle is given at 30, A is Y, and H is 650. If I want to know what Y equals, I need to get it on its own. So my divide by 650 is going to move. It's going to land as times. So I'm going to end up with Y equaling 650 times cos 30. Now, we would normally put this into our calculator, but we're on a non-calculator paper and they still expect me to answer the question. If I couldn't get any further than this, I'm probably picking up a mark because I'm demonstrating I understand what to do, but I'm now stuck because I haven't remembered the table. So the table is key to completing this. So I need to know what the value of cos 30 is. For now, we are going to keep checking in with our table because we don't know these off by heart. And I can see that the answer is root 3 over 2. So I've now got 650 times, what did I say? Root 3 over 2. Remember when we multiply fractions, and I'm just going to show that so we don't forget this little detail. The whole number will always multiply into the numerator only. So this is now giving me 650 root 3 over 2. I can now divide by 2, and I will end up with 325 root 3. And that is the answer. Keep the units as well. And it's the perfect answer. So it isn't any different to basic SOHCAHTOA, except we've got to do a little bit of extra work on the end by hand. All right, let's do another one. So let's clean this off and get another one drawn in. So let's do, there's my right angle triangle. We've got 2a and root 3 over here. I want you to pause and just have a go. We are not going to get better at this or start to appreciate what to do with this unless we dive in. So just go for it. Hit play when you're ready. Okay, so I'm going to label the sides opposite, hypotenuse, adjacent. The sides that I need are this one because it has some value, and this one. So it's O and H. So SOHCAHTOA, O and H, as you can clearly see, is here with the sign. So it's sine theta equals opposite of hypotenuse. Now, if you're taking shortcuts and not doing any of this, that's your choice. But if you are someone that can easily choose the wrong function or make a mistake, don't take any shortcuts. That there is proper structure, something to follow and reduce chances of going wrong. So now I'm going to put in the information I can see from the diagram. So I've got sine, I need the angle. Angle is A. O is root 3, H is 2. If I want to know what A equals, I've got to get it on its own. So the question is, do we really need to do this, I suppose? In a calculator, we would be using that button with this and getting our answer. And there would be nothing wrong in writing that out. But equally, you could argue, all I really need to do is get that root 3 over 2 in my head. I know it goes in the order root 1, root 2, root 3. So I know 0, 30, 45, 60. So I should know that it's just 60. So what I could do is just write this first bit, not worry about that. That's kind of what we do with the calculator. Write this bit here and then kind of show it again, but this time inserting the 60 like this, and then you can write A is equal to 60 degrees, and that would work equally as well. So there's no right or wrong way of doing it. Okay, now if that went well, brilliant. All right, it's just having that confidence to manipulate the information from the diagram and then link it to the table. That's all it is. Okay, right, let's do another one. Again, I'd really like you to just hit that pause button and press play when you've had a go at it. I'm going to put A on here, 1, and root 3. All right, so press play when you're ready. Okay, so I've got opposite, hypotenuse, adjacent. So I've got these two. Sokotoa. Doing this every time, O and A, so I don't get lost. And if you haven't done trig in a little while, hopefully this is helping as well. So write out the actual function first, and then O is 1 and root 3. So that is the same as now 1 root 3. I know that the fraction is the first one, so that's 30 degrees. So I've got tan 30 equaling 1 over root 3. Therefore, A is equal to 30 degrees. Okay. Hopefully this is starting to feel good and doable for you. Here we go. So I'm going to say we've got 30 degrees, 2 meters, and E. Press pause and hit play when you're ready. Okay, so we've got O, H, and A. I tend to label them all, even though I don't necessarily need to. I've got H and O in this one, so it's sign, as I say, if it's helpful, you should write it out every time. Okay, what have I got? I've got sine 30 equaling my opposite, which is E, and my hypotenuse, which is 2. So that's telling me that E is equal to 2 times sine 30. If I want to know what E equals, I get it on its own. Okay, so that divide by 2 goes across, lands as times by 2. So all I've done is just that rearrangement within the equation so that I can go on and solve this. Now, I'm expected to know what sine 30 is, okay? So if I do my V for victory, I know that I've got the root 1 at the top with the 2 on the bottom, and I've got 2 times that. Write this properly, and you've got 2 root 1 over 2. The 2's cancel, and actually the square root of 1 is 1. So the final answer for that one is an edge of 1. Okay, slightly different question now. Okay, show that tan 45 plus sine 60 is equal to 2 plus root 3 over 2. Okay, so hit pause, go with your guts, and press play when you're ready. Okay, so you'll work out, you'll use your knowledge of the table to find tan 45 is 1 plus, and sine 60 is root 3 over 2. Okay, now this is a fraction, and when you add fractions, although I can't see that as a fraction at the moment, but I will in a moment, their denominators have to be the same. So 1 over 1 is the way to express 1 as a fraction. Always just put whatever the whole number is over 1. But obviously that denominator isn't the same. So what I'm going to do is multiply it up to give an equivalent fraction. So timesing by 2, top and bottom, will give me 2 over 2. That's still worth 1. Haven't changed anything, just written an equivalent fraction. Okay. And then that can be written as 2 plus root 3 all over 2. So that's how we would show that. And I think it's just having that confidence, once you've got the denominator the same, just knowing and understanding that you can just stretch that line across whatever the numerator is and just write it the once. If that's something you haven't had a lot of experience with, then that is probably a less intuitive step, let's say. Okay, I'm going to leave it there for this. We are moving on. There is more to the session today. You're not getting away with it that easy. You need to learn the table, obviously. And one of the things that you need, I think, to be able to do is the minute you see a question that requires you to recall a piece of information from that table, you should be able to just, boom, write the whole thing out. Just write the whole thing out, or write it until you've got the information you need so that you're not wasting time, but write it out. And just learn how to do it in a way that works for you. So V for Victory has had quite a lot of success in the classroom, so it could be a way of remembering it. Okay, we are moving on to another way we can make our basic SOHCAHTOA harder and therefore have it on the higher GCSE. And what they will be doing is giving you wordy questions. Let's just move that down so we can see it. There we go. They're going to give you wordy questions, a bit cross-topic, or use language that we're a little less familiar with, that type of thing. So it's harder, a lot harder to prepare for these types of questions because they look different all the time. So I can't sit here and just go through everything you need to know. So you've got this safety net, if you like, going into the exam because you'll have seen it at least once. I can't. What we have to know is if they are describing a story or giving a diagram that has right-angled triangles in it, then there's a good chance that our trig is going to come into the problem solving. And that's the ticket, that's the key, that's what we need to remember. If I'm seeing right-angled triangles, I am quite likely going to problem solve with my SOHCAHTOA. Right, I have a selection of examples. What I would recommend you do is, obviously, I'm sure you do it anyway, but is get every single one down as examples. If you're having a go, then you have a go. But once I've talked you through it, you've got that really clearly written out as an example, so that when you are more on your own with the questions at the end of the session or with your recap questions, you've got a go-to page which kind of shows you all the different things that we've done. Okay, let's have a look at this one to start off with. So we've got a plane leaving an airport. It flies 60 kilometers on a bearing of 278 degrees. How far west has the helicopter flown? Okay, so this is bringing in bearings. So it's a real classic example of that cross topic that I was talking about. And if we don't know bearings, we are already on the back foot. Bearings are a grade 5 topic. I will go through what bearings are so that you are able to go on and do more questions in this style. Okay, in case you haven't remembered. If you have remembered, feel free to pause and give this a go. If you want that kind of initial talk through, then obviously stay with me. Okay, the first thing that's wrong with this question is there's no diagram. We need diagrams. We are better at producing our maths and knowing how to problem solve with our knowledge if we've got a diagram to hinge to. So really, really important that we have the diagram. So I've got a plane leaving an airport. So I'm going to, first of all, say that that is my airport. It flies on a bearing of 278. Now, bearings are always measured from a north line. So there's my north line. They are always measured clockwise. So I'm going to do 278 degrees, okay, which I'm going to say is roughly there, okay. And that's the direction that my plane is traveling in, okay. So let's draw that up so it's complete. I know that that side is 278 degrees, okay. I know the plane starts here and travels along this line. I know it travels 60 kilometers, so I can label that in as 60. It says how far west has the, oh, it's gone from plane to helicopter. I should concentrate when I write these questions, shouldn't I? Okay, let's say helicopter. How far west has the helicopter flown? Well, west is this direction. And if that's where his end point is, come straight down, and there's my right-angled triangle. Okay, and it's this, how far west has it flown, that I want to work out. So this edge here. At the moment, my triangle does not have any angles in it. So that's my next job. I need to be working out at least one of these angles so that I can use trig in the first place. So this is what I'm going to be doing. I'm going to find this angle because that one is easy for me to find. I know the angles around a point of 360. So 360, take away the 278 is going to leave me 82. Okay, so I know that that is 82. I also know that the angle between north and west is 90 degrees. So I know from here to here is 90 degrees. 90 take away 82 is 8 degrees. So I now know that that is 8 degrees. So that is a huge amount of work to do just to get started on this question. But without that, I can't get started. So I have to be thinking about modeling the story so that I can start to build a picture of what I've got available to me to solve it. And of course, once I've done all of that, I can then see that right angled triangle. I know that I'm going down a path of trig, because whilst we're doing it in this session, we know it's trig. Everything I'm doing with you today is trig. But if that question had come up on a GCSE paper and you've got that keyword bearing, what you tend to do is hold yourself back by only thinking about bearings. But when you draw the model and you start seeing the bigger picture, then you can start seeing other elements to it. But without the picture, you see nothing other than what's in the question. And the only thing in the question is bearings, which is nowhere near enough to help you solve the question. Okay, I'm going to redraw my triangle now, just so that I've got it outside of the diagram. I know that I'm looking for this. I know that is 8 degrees. I know this edge is 60. I am going to label up my sides O, A, H, write down my soccer toa. I've got A and H, so I've got cos. Okay, let's get my pen back. So cos theta is A over H. Cos theta is 8. A is X. H is 60. So my divide by 60 is going to land as times 60. So I now know that my X, how far west it traveled, is going to equal 60 times cos 8. And 60 times cos 8 into the calculator gives me 59.416 or 59.4 kilometers to 1 decimal place. Okay, so you can see that combining the topics creates a much bigger problem. So that's an example of how we can bring trig and bearings together. We're going to look at another question now. There we go. I'll just clean this off so we're not distracted by it. So the sun is at an angle of elevation of 58 degrees. So we've got that key word elevation. And again, if we can't work with that, we're going to find this hard. A tree casts a shadow that's 20 foot long on the ground. How tall is the tree? Once again, without a diagram, we can't see what it is we need to do. So I want you to hit pause and have a go at pulling that diagram together. Then I want you to hit play and check your diagram. If your diagram is correct, hit that pause and keep going with the problem. If it's incorrect, correct it when you see my diagram, and then hit pause and go on and finish it. So do it in stages rather than do the whole thing and then find you made a mistake with the diagram. That's all we're trying to do, save a bit of time. Okay, so pause, check in once you've got your diagram. Okay, so this is the ground. The sun is obviously in the sky, up there somewhere. The angle of elevation is measured from the ground towards the sun. So my angle of elevation, they're telling me, is 58. A tree is casting a shadow. Now, a tree is going to be my vertical straight up line in my model, okay? So that's my tree. So now I've got my shadow, which is this length here from the tree to the angle that measures the elevation of 20. Tree is making a right angle with the ground, and I can see everything I need. And there is nothing wrong in drawing full-on pictures if it helps bring the story to life for you and helps you see the triangle. Okay, so I'm just going to redraw this now. So it's just a nice, simple, it's clearly not going to be drawn to scale, but we will see. Doesn't matter anyway, does it? Okay, I want to know the height of the tree, so I want to know that edge. Right angled triangle tells me SOHCAHTOA. I have got the opposite, hypotenuse is over there, and the adjacent. So I've got the opposite and the adjacent, so this is TOA. So it's going to be tan theta is O over A, tan 58. The opposite is my X, the A is my 20. So again, that is going across. And I've got X is equal to 20 times tan 58. And when I pop that in my calculator, I get 32.0066. So 32 feet. That is the height of my tree. And if you got that right, really, really well done. Okay, because I do think these questions are tough. And if you are finding them challenging, do not worry about it. Just be resilient. Just keep trying. The more we do these types of questions, the easier and the better they will become. You are here learning about grade 6 skills, but when we start applying them, sometimes that can stretch into higher grades. It would be silly of me to not include that and cap you. We want to be able to see everything all at the same time, right? So if it's hard, don't worry, you just keep trying. If you can get half the marks, you're getting more than you were before. And always remember that. It's not about perfection always. That's the ultimate goal, but if you can pick up 1 here or 2 here, that's more than you were picking up before. You are making progress, okay? Right, here's our next question. So we have got a 3D shape. We've got a cuboid. We need to find the angle BDF, okay? Once again, I want you to have a go at this. And I want you to pause and play, and then pause again and play again as many times as you want to. All right, so if you want to have a go and then you hit the play and see something that you didn't do, but don't want to see the rest of the solution, you just want to pause, correct that bit, and then carry on having a go. Do it like that, because it will help you, okay? If you want to stay in that comfort zone and watch the whole thing play out, that's fine. But do make sure that you're writing these down as examples. Like I say, we've got the exercise at the end, and we've got our recaps coming up. So the more you've got clear for you to go back and look at, the better. Anyway, hit pause, have a try with this one. Okay, so the first thing that I do is as I pull out the triangle that they're talking about. So it says I've got to find the angle BDF, okay? B is here, D is straight across the diagonal of the base. So that is my B to D. F is straight through the space, the middle of my actual cuboid. And then obviously, F and B finish it off. So I'm here along the bottom through the diagonal, and then up right across through the middle of the actual space inside the cuboid. So I kind of draw that. So that's my F to B. That's me coming across and going up. And even though I haven't really drawn a right angle, it gives me a better feel for what I'm looking at, and I don't lose sight of my problem. So I do this. You don't have to. Some people are much more comfortable going straight to the right angle, and that's fine, okay? I still mark that on as my rectangle, my right angle. We can see, I'm hoping maybe a little bit of color might work out here. So I'm coming down and then across, and that vertical with the base is obviously making a right angle, even though it's not overly obvious. I'm also going to put on the fact that I've got my F, my B, and my D. I know that my F to B is 4 centimeters. That height is being given here, okay? So I know that fact. They want me to find angle BDF, so I need to find that angle, okay? My problem is I need another edge. I don't have enough information to find an angle yet. I always need 2 edges to find an angle. So I can't go straight in to the problem. I'm going to have to do another step first. Now, for me, the obvious step is to find the missing edge BD. If I can find this edge here, all right, so this edge here, if I can find that, then I've got the number I need. And I can, because the base has got 2 pieces of information, which is a lot more information than anywhere else in the diagram. So it's going to help me. So let's draw that out. That's A, B, C, D. That's the base. I know that's 6 centimeters. I know that's 7 centimeters. And I know I want to find that edge there. That edge there, once I've drawn it in, is making a triangle with ABD or with BCD, whatever way around I want to think about it. So I have Pythag in this question. I've got 2 edges. Yeah, I've got the 7 and the 6. And I want to find this 3rd edge. So that is Pythag. I want to find the hypotenuse. A squared plus B squared equals C squared. Okay, and I've got the A and the B. So it's 6 squared plus 7 squared equaling c squared. 6 squared plus c squared is 85. Square root that, and that's my missing side, or my BD. So now I know that this is the square root of 85. Okay, now I can hit that S to D, I can see it as a decimal. Don't round your decimal if you're going to use that to do your workings out with. Make sure you keep at least 4 decimal places so that you don't end up with an error due to rounding. Just don't round, okay? Last step now is to finish off this question over here, okay? I've got this, I'm good to go. My opposite is 4 and my adjacent is 5. So I've got an opposite and an adjacent, which means it's tan. I'm going to go straight into it this time. Tan theta, the opposite is 4, the adjacent is root 85. Okay, the angle, get it on its own. So I've now hopped the tan to the other side, so the inverse is landed. And I put 4 root 85 into my calculator, which I need to do. And then that gives me the angle that I'm trying to find. So let's quickly do that. Okay. Sorry, my calculator was being funny there. So we've got 23.454 and on it goes. So to 1 decimal place, 23.5 degrees. And again, you've got that multi-step problem, and trig ended up getting combined not just with a 3D shape, but with Pythag as well. And often where there's right angle triangles, there's trig, but there can be Pythag too. The two go really hand in hand. Okay, one more example, and then you are on to your practice. Okay, so good old circle theorems. Nice to see it. If I can make a right angle triangle, it doesn't matter where or in what topic, I can bring trig or Pythag in, can't I? All right, so I want you to hit the pause button and, as I say, have a really good go at this question. And then when you're ready, hit play. Okay, so we can see that we've got a tangent to radius. Now, a tangent to radius is always going to give me the right angle. So I can't get my words out. Is going to get me that right angle. So that's my first fact. I know if trig is in this problem and our session is trig, so it's got to be in there somewhere, then that's going to be a good place for me to start because of the 90 degrees. Okay, so I'll mark that on. If I split through this middle here, okay, I know that I'm bisecting the angle, so I know that I've got a 21 degree angle here. Okay, and then that will enable me to start finding some of these missing edges. Okay, so let's make a start with that. So what we're looking at this point is our right angle, our 21 degrees, and our 7. Okay, now what this is going to do, so this is the first thing that's jumped out of the diagram. What this is going to do is help me to either find this edge here, which is this edge, or it's going to help me find this edge here, which is the edge straight through the middle. which is this edge. Now, if we think about this before we start cracking on, how exactly are those two edges going to help me find AB, which is actually the problem that I'm supposed to be working on? So what I've done is I've dived in, looking at what I can see and what I know. I went straight in with the first triangle that I could see, but it's not helpful. All right. And it's a normal part of problem solving. It's a normal process. Nobody just problem solves perfectly the first time. So you might have even gone on and found those actual missing edges before you realized that they weren't going to work. So instead, I need to go back and look at what I've got in that diagram that's going to help me. And I do have another right angle. Okay. Now I've put this line in, I can see it bisects the chord here, and it will bisect it evenly. Okay. It's cutting it through the middle. And it's creating a right angle here. So I've actually got a right angle triangle right there, but I don't have another angle. I don't know what that one is there, and I don't know what that one is there, but I do have enough information to work it out. Because, and I know there's a lot of color, so it's starting to get a little bit busy, but we will still add more. This here, and it's going to be a bit wobbly, but it'll do what I want it to do. That there is a kite. It's a quadrilateral. And I know that they have to add up to 360 degrees. I know I've got 90 here, 90 here, and although I've colored over it, I had 42 there. So 360, take away the two right angles and the 42 degrees, is going to give me 138. That 138 is that angle there, okay? I only want half of that angle, which is 69, and then I've got enough to do 69, right angle, and 7. I've not made it big enough to write 69 in. Let's just stretch it out a bit. There we go, I can squeeze it in there now. Little skinny 69, look. Okay, so I have opposite over here. I have hypotenuse here. I have adjacent here. Remember, what we're trying to find is AB, which is that one there. So it is the O and the H that's going to help me here. So O and H is sine. So I've got sine 69 is my opposite over hypotenuse, which is 7. So the opposite is 7 times sine 69. Remember that moves and lands as a times. Pop that in the calculator and I get 6.535 and on it goes. Don't think you've finished at this stage. Remember, we've only worked on half the diagram, half AB. Yeah, because we just took out that one small right angle. I want the whole of AB. So I've got to times that by 2. And then I get my final answer of 13.07. On and on it goes, which is 13.1 centimeters. Whew. Big, big questions, aren't they? Lots of maths happening in these. So it is a case of just taking your time. Don't worry if your first pathway that you think of hits a dead end. That is part of problem solving. All you do is rewind. There might be something that you did in that that's going to help you anyway. And then you try something new. Okay. So for us, even though this was a dead end, there was something that was useful that came out of it. And that was this line that I drew in because it meant I could see more right angles here. All right. So it wasn't a complete waste of time. Okay, these are your questions. You may feel, if you haven't had a break yet, that it is time to take one. So those are the questions that I've selected. Let's get rid of me because you don't really need me anymore. Just as I say, take your time. Please don't worry about it too much if you are finding it tricky at this stage. That's normal. Just give it your best shot. That's all you can do at the end of the day. And your answers are coming up. Just rewind and move between the two, and I will see you next session.